everyone, it's Miss B, and in this video we're looking at the Unit 3, Lesson 4 Cumulative Practice Problems for Illustrative Math Geometry. So this first question is just asking us about an angle. So we have angle ABC is taken by dilation with center P and scale factor 3 to angle A prime, B prime, C prime. So the measure of angle ABC, our original angle, is 21 degrees. What is the measure of angle A prime, B prime, C prime? Well, the angle measure is still 21 degrees, and I'm going to write 21 degrees because dilations do not change angle measure. Change angle measure. And that was the big part of this lesson, is that dilations don't change angle measure. So that brings us to question 2, which is this big series of lines. We want to select all lines that could be the image of line M by a dilation. So let's identify where line M is. I am going to say, oh, it's right here. I'm going to highlight it just so that I have an idea of what line I'm looking at here first. Okay, so line M. And then we want everything that could be a dilation of line M. So we know, first off, that pretty much a dilation, if the center of dilation is on the line, it can take it to itself. It's just going to maintain and be the same line still. So that means I can identify over here that B is one of the correct answers because that says line M. And that means that line M would just be itself. It could be its own image if the center of dilation is on the line. Now, the other principle that we learned is that lines are, when they're dilated, are parallel. So the only other ones I see that are parallel here are lines N and line P. So those are my two other ones that are parallel. And let's find those in our answers over here. That's going to be C, or options C and E. So to itself or to parallels. So that brings us down to question 3. Question 3, they say dilate line F with a scale factor of 2, and the image is line G. So which labeled point could be the center of this dilation? Okay, so they're asking us A, B, C, or D, but line F. So line F is our original one here. This is our blue line. And if our scale factor is 2, that is kind of important here. So I'm actually going to highlight that in my scale factor of 2. Since this is bigger than 1, it means it's going to be moving away from the center of the dilation. So it's going to be getting further away. It would be twice as far. So that means, I'm going to write that little note here, right? Further away, further from center as my little note to myself. So that means I'm not going to have it be A. I'm going to cancel that one out or cross it out because A is actually closer to line G. And the image is line G. So the image is the new, or what's created, right? So F is our original. And if we dilated it and it moved to G, if it was getting smaller or our scale factor was less than 1, then G is an option, but it's not here if we're using A, so A is not an option for us. The only one that it's actually moving further away from, well, there are 2 that it's moving further away from. It's moving further away from C and further away from D. So we're not going to use B either. And point C is on line F. So if we dilate a line by a point that's on the line, it's going to be the same line instead of moving off of that point. So we're not going to use C either. It has to be D as our answer. So I can write that down as my answer for that one. For question 4, we have quadrilateral A prime, B prime, C prime, E prime. It's the image of A, B, C, E after a dilation centered at F. So I see they gave me a center of F. I'm going to highlight F here. What is the scale factor? And show how you got your answer. Okay. So my scale factor is going to be something from my image divided by a corresponding piece from my pre-image. Or you can think about these as, if they say it's a scaled copy, it's something from your original and something from your copy, you would do the copy divided by the original. But in this case, we're going to use image and pre-image. So my image, I'm going to use these numbers right here. I'm going to select just the top line here, so BC and B prime C prime. So our image is B prime C prime, and the pre-image is BC. So I'm actually just going to kind of write this as a series of equations here. So B prime C prime, that means 3 goes on top, and then 6 here goes on the bottom, and we reduce that to 1/2. Now, if you're comfortable with 1/2 being your answer, great, but you can also check. I like to check, is it greater than or smaller than 1? And is my image greater than or smaller than my pre-image? So 1/2 is less than 1, and image is smaller. So I'm gonna, that was a wonky looking check mark. That's kind of how I check myself on it, because I know that oftentimes I'll use the right numbers, but it's how I check that I'm not accidentally doing the reciprocal. So just checking whether or not it's greater than or less than 1, and does that match up with my picture? That means we're now moving on to the next part of our question here, which is, or next part of our homework, which is question 5. We have a polygon with a perimeter of 18 units, and it's dilated with a scale factor of 3/2. So what is the perimeter of its image, and show how you got your answer. So I'm going to show my work here. We're really just going to take this perimeter, 18, and multiply it by that scale factor, 3/2. Now this is the same thing as dividing by 2 and then multiplying by 3, or multiplying by 1/2. I like to think of it as divide by 2 and then multiply by 3. So 18 divided by 2 is 9, and then times 3 over the 1. If we kind of cancel here, 9 and 1, right? Then 9 times 3, 27. So my answer should be 27, and that is one of the options they give here as well. But since they said show my work, I'm showing my multiplication. That brings us to question 6. For question 6, we're just looking at a proportion here. So we want to solve and show all of our work. I'm going to zoom in so I don't have a bunch of other stuff distracting on the screen. I'm going to do this by cross multiplication. I like to multiply with my variable first. So I'm going to do 4 times x and put 4x on the left. And then we'll do 7 times 10 on the right-hand side. Okay, so this would then be 4x equals 70, and we would divide both sides here by 4. That leaves us with x equals 70/4. We're going to reduce this as far as possible. It's only going to reduce by 2, so it'll be 35/2. And you can write this out as a decimal as well. That's fine, but I like to leave mine as fractions. So we're almost done here. Question 7. We have some measurements from the angles of a triangle. So triangle ABC and XYZ. And some people arguing about whether or not they're congruent. Since they don't give me a picture, I'm going to draw a picture of my triangles here. I process things best visually, so I will write or draw out my triangles here. And then we'll actually look at what the question is asking. So ABC and XYZ, and they're giving us some that are both 30 degrees. So I'm going to start by trying to draw a 30-degree angle here. 45 degrees would be about halfway, so I'm going to say 30 degrees is maybe like here. We'll draw it a little longer. Okay, so C, and then this was, sorry, CAB. So C, A, B, and then I'll just connect B and C here. Okay, so I can say that this is my 30-degree angle. AC and XZ both measure 3 units, so I'm going to write 3 here, and CB measures 2 units, so I have 2 units here. Okay, now I need to draw triangle XYZ, but they're trying to ask, they're saying Andre thinks these triangles must be congruent, and Claire says she knows they might not be. We want to construct the 2 triangles with the given measurements that are not congruent. Okay, I'm glad I read this before I just went about drawing another triangle. So we want to explain why they aren't necessarily congruent after we draw it. So, okay, we're still going to draw our 30-degree angle. But that is, I don't want a circle. I'm trying to draw a line, a straight line here. Okay, I can still draw a straight line here and make a 30-degree angle, but have my, and I don't want a curve. We can have 2 different looking triangles where the angle that's at B is actually a different measurement. So, or it's not at B, I'm sorry. This is now triangle XYZ, that was my bad. 2 and 2. Oh, okay. Got it. I was trying to think there's a way to do this and I kind of messed it up a little bit. But I'm still going to have my 30-degree angle, but I now want to construct a side that is of length 2 that does not work with this while I still have a side length of 3. So in this case, oh, you know what? I can even just copy this triangle and make it work here. Let's copy this, and I am going to make a copy of this that does not quite add up, and I'll be able to show you the exact difference. So I still want that side length to be 2 and to be 3, but that doesn't mean that my side length on the bottom here, which is AB on my original triangle, that does not need to stay the same. And so this is what's actually going to extend, and we are going to draw a segment of side length 2 that comes down this way. And so we essentially have something that's almost equilateral looking in that little gap. This is what creates 2 triangles that are not congruent, but have those same 3 pieces of measurement. And so let's label this correctly because we want it to be X, Y, and Z. So they said it was ZY is 2 units, and so it was ZXY, so ZX and Y. So I'm just going to make sure that these match up. They said ZXZ is 3 units, good. ZY is 2 units, we're good here. And ZXY is 30. So these are both definitely different because I have one side extending further out to the right on the top, and in triangle XYZ, it extends further to the right on the bottom instead. So how can we say that these aren't congruent? We have to explain why. Well, you can say not all combinations of 3 parts so not all combinations will have those pieces congruent. So all combinations will create congruent triangles. Now, if you want to be more specific, which in this case they are asking you to try to be more specific, this is side-side angle, but side-side angle only works when the longer of the 2 sides is opposite of the angle. And in this case, we don't have that. So we just kind of don't address side-side angle as a way to prove congruence at all. So we're just gonna summarize and say not all combinations create congruent triangles when you have SSA. So we have angle, side, 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 side. And there we go. So that was everything for this assignment, because the next assignment on my list here is number 5. So thank you for joining me for Unit 3, Lesson 4, Cumulative Practice Problems for Illustrative Math Geometry.